Since its introduction in 2016, the SpaceX Starship has been seen as a joke by billionaire Elon Musk. More than half of those who know it say it's only a money-burning project and Starship will never fly. However, this is how SpaceX responded to them. This is also the reason Musk is always confident. I don't do this to criticize anyone, this just proves that SpaceX's Starship has created something extraordinary, and honestly, their skepticism was perfectly natural. Starship possesses concepts that had not ever existed before in the rocket industry. One aspect of Starship that drew skepticism was the unconventional choice of stainless steel as the primary construction material. Critics argued that stainless steel was relatively heavy compared to carbon composites commonly used in aerospace applications. Concerns were raised about the impact on weight efficiency and overall performance. In fact, when deciding what to construct the body of a rocket out of, many materials are quickly eliminated. Whatever material you end up going with has to have many desirable properties. It has to be strong enough to support the weight of the rocket payload, propellant, and body, while also being light enough to not be a significant weight contribution. It has to be able to handle the massive temperature swings of storing incredibly cold cryogenic fuel while maintaining integrity during the extremely high temperatures experienced during re-entry. You also want your material to be as cheap as possible. The majority of rockets use either aluminum or titanium for their main body, with other parts being made out of carbon composites. Starship's being made out of steel, specifically a combination of 301 and 304L stainless steel. Titanium and aluminum, both being light and strong metals, tend to fail between 300 and 400 degrees Fahrenheit, while steel can get up to 15 to 1600 Fahrenheit. Steel also tends to become stronger when dealing with low cryogenic temperatures, something the other two don't. Carbon composites may be promising in the future as they're very lightweight yet strong materials. Unfortunately, they're expensive when compared to steel. According to a statement from Elon in 2019, SpaceX was spending close to $200 a kilogram of carbon fiber compared to $3 per kilogram they paid for steel. This switch to steel has allowed SpaceX to prototype and iterate at a rapid pace that they wouldn't have been able to do if they were still using carbon composites. Next, it's Raptor. The rocket engine that'll loft Starship into orbit is SpaceX's Raptor engine. A feat of engineering on its own, the Raptor previously set a rocketry record by achieving the highest combustion chamber pressure ever of 350 bar, which produces over 500,000 pounds of force. The Raptor is also the only engine in existence to use the full flow staged combustion cycle for power, a historically hard process to implement. A full flow staged combustion cycle refers to how a pump spins a turbine to drive the engine, using what's called a preburner to get this process going by injecting a small amount of fuel. Normally, some of the propellant is expended in a traditional open cycle engine to start this process, but Raptor will use every drop of propellant available, making it one of the most efficient rocket engines ever built. Raptor burns fuel at a high enough pressure that can steer the fire from the preburner back into the combustion chamber and completely burn that propellant with the rest of the propellants, says space consultant Charlie Garcia from MIT. And it does this in a very clever way that only the Russians have done previously, by putting all the propellant in the engine through the preburners. The end result is that Raptor has a much higher pressure than Merlin, about 3 times greater, making it the highest pressure rocket engine in existence and leading to its aforementioned larger thrust than Merlin despite its similar size. In 2016, Musk referred to the insane pressure inside the main chamber of the engine, 300 bars, which required the development of a new metal alloy. The other is the use of methane. No methane-powered rocket has ever made it to orbit, with Starhopper's test hop the other day being the first time a methane-powered rocket engine had actually taken flight. Methane prevents a buildup of deposits in the engine compared to other fuels like kerosene, a process known as coking, while its higher performance allows for lower costs. Historically, the 2 rocket fuels of choice are kerosene, also known as RP-1, and hydrogen. For example, the Saturn V used kerosene, and the Space Shuttle used hydrogen. Without going too far into the details, the main reason for these choices over other fuels come down to energy and storage. Hydrogen, when burned with oxygen, releases a lot of energy. In fact, it's nearly impossible to find a more energetic fuel suitable for high-velocity rocket exhaust than hydrogen. So why not use hydrogen? Well, it's not easy to store. Hydrogen, with its high vapor pressure, tends to boil quickly. This becomes a problem when your liquid hydrogen tank warms up inside the rocket while it's sitting on the launch pad waiting to go. It's also unsuitable for long-term storage due to hydrogen's tendency to cause hydrogen embrittlement in metal storage tanks like the ones being used on Starship, reducing the strength of the metal over time. On the other side of things is kerosene. The type used in rockets is a highly refined grade of kerosene called RP1. Very popular in launch vehicles, especially for the main booster stage, kerosene has none of the storage problems hydrogen has. RP1 can happily sit in a liquid state on the launch pad for hours and not cause any problems. So why not use kerosene? While not quite as energetic as hydrogen, the real issue when using kerosene is the coking problem. When kerosene is burned, it releases unwanted byproducts, mainly soot. The soot tends to clog engines over time, making reuse of engine components without refurbishment a nightmare. The Raptors specifically are aiming to be as reusable as possible. So that leaves methane, which seems like the rocket fuel choice of the future. Liquid methane sits in the middle of other rocket fuels. Not as energetic as hydrogen, it can be stored long-term in metal containers. It's not as easy to handle as kerosene, but it's more energetic without having the coking problem. As an added bonus, methane can be made on the surface of Mars relatively easy, which kerosene can't. This makes methane the ideal choice for a rocket vehicle designed to launch to and from the Red Planet. Finally, an insane concept is the ability to refuel in space. Science fiction author Robert Heinlein once said in an interview, "If you can get your ship into orbit, you're halfway to anywhere." It turns out that roughly half of all the energy expended traveling to anywhere in the solar system, be it the Moon, Mars, or even the outer planets, is spent just getting into the orbit of Earth. The problem is that for every kilogram of payload you also have to have the fuel to lift it into orbit. But then that fuel also needs additional fuel to lift the first amount. Eventually, the math works out to be that you need an absurdly large rocket to go anywhere at all. The exception to this is if you're already able to refuel your rocket while it's in orbit already. This is the plan for Starship, in-orbit refueling. It's a step so critical to leaving our planet behind that NASA has announced that they'll work with SpaceX to tackle the problem. The SpaceX plan is to send up a single Starship into orbit first. Then, additional tanker Starships will be sent up in sequence afterward. These tankers will rendezvous with the first Starship and transfer their excess fuel into it. This way, Starship will double its capacity to visit other destinations in the solar system. In-orbit refueling won't be easy. The task of automatic docking has been demonstrated to be within SpaceX's capability with the Dragon demo missions to the International Space Station. But transferring large amounts of propellant between two spacecrafts of this size has never been done before. In space, liquids tend to spread out within their containers. Pulling off the maneuver will take a great deal of coordination between the two starships. In short, the journey of SpaceX's Starship project has been characterized by skepticism, doubts, and challenges. The road to success is definitely still far. However, through a relentless pursuit of innovation, the first Starship orbital flight has defied the initial doubters and silenced the skeptics. The ability to confront doubts head-on and overcome technical challenges is a testament to SpaceX's ingenuity, resilience, and commitment to pushing the boundaries of human achievement. As Starship continues to evolve and reach new milestones, it paves the way for a future where space travel and colonization become routine, leaving behind a legacy of daring to dream big and proving the skeptics wrong. Elon Musk, the world's wealthiest billionaire now, is renowned for his audacious and imaginative statements. One of his most astonishing claims pertains to the price of Starship launches. When the spacecraft enters regular operation, only $2 million? Yeah, okay. When he said this, everyone laughed at him. SpaceX will have eventually spent $5 billion or more on its Starship vehicle and launch infrastructure by the end of the year. So what does the cost of Starship launch look like when it's launching regularly? SpaceX achieved a significant milestone on Monday, June 26th, as it successfully performed a static fire test of Starship SN-25, the upper stage prototype attempted for the second flight attempt to orbit. The test took place at 7:27 p.m. Central Time at SpaceX's Starbase, Texas launch facility. It involved igniting all 6 SN-25's Raptor engines for approximately 5 seconds. Static fire tests are routine pre-launch procedures that verify the functionality and performance of a rocket's engines while the vehicle remains firmly grounded on the launch mount. Key milestone completed for Flight 2, SpaceX chief engineer Elon Musk said after the test ignition. This is also the prelude to Mars, Musk added. So when Starship starts going up regularly, it'll really change the way we go to space. More importantly, by fully reusing the vehicle and eliminating any need to discard expensive flight hardware, the cost reductions to SpaceX will likely be massive. Musk himself has stated that SpaceX's costs could be as low as $2 million a launch, while analysts have suggested something around $10 million might be more reasonable. At a $10 million cost per launch, putting 100 tons of payload into orbit would come to about $100 per kilogram. The current cost to SpaceX for a Falcon 9 launch is likely somewhere around $3,400 per kilogram, and so Starship's current cost per kilogram is a very tall order. Because of that, it seems understandable why some think that Starship is going to change the game. However, if we want to increase our access to space, then cost necessarily isn't the key indicator that we should be tracking. SpaceX is going to need to pass those cost reductions onto its customers in order for satellite providers to reap the benefits. This is where a lot of the skepticism is, because it seems that there's little incentive for SpaceX to pass on those savings or any precedent that they'll do so in the future. Let's explain. On December 15, 2015, SpaceX accomplished the seemingly impossible. They successfully landed the first stage of a rocket for the first time. This meant that SpaceX would soon start reusing its Falcon 9 first stages, an innovation that could seemingly slash the cost of getting into orbit. Just 3 months later, SpaceX President Gwen Shotwell spoke at the Satellite 2016 conference in Maryland. At the time, she speculated on what Falcon 9 first-stage reusability might mean for SpaceX customers, citing that it could potentially reduce prices by 30%. That's down $40 million a launch, and at that time, a Falcon 9 launch ran $61.2 million. This wasn't the first time SpaceX leadership openly contemplated how reusability would impact prices. Looking even further back to the Singapore Satellite Industry Forum in 2013, Shotwell there speculated that Falcon 9 reusability could mean launch prices to customers as low as $5 to $7 million. Well, it's been 10 years since the 2013 mention of $5 to $7 million prices, and 7 years from the 2016 speculation of the $40 million prices. Since that time, SpaceX has widely surpassed the industry's expectations on reusability, flying some of its first-stage boosters over 10 times. So what is a Falcon 9 launch priced at today? $67 million. The price has actually increased about $5.8 million from the pricing in 2016. And if we take inflation into account, the real price hasn't increased that much over time, but has actually stayed the same. So what happened there? Did SpaceX's cost benefit from reusability not materialize? Actually, this is just because SpaceX hasn't passed any of those savings onto its customers. They simply expanded their margins and made more money on each launch. And actually, that's entirely understandable. When fully expendable in 2015, the Falcon 9 was already the cheapest launch vehicle in its lift class at $61.2 million per launch. Today, at $67 million, that's still the case. In fact, a ride on the Atlas V rocket is twice that. Not that you could get a ride on the Atlas V anyway, they're all sold out until its retirement. Also, since 2015, the Falcon 9 vehicle has become arguably the most reliable rocket on the market, with over 115 successful launches in a row. And with no competition out there putting pricing pressure on SpaceX, why would they reduce their prices? You could make a strong argument that they should actually be raising them, which they are. SpaceX is laser-focused on getting humanity to Mars, an enormously expensive ambition. And right now, it's not in their interest to charitably pass savings on to customers when they already offer the best product on the market. Just look at the launch frequency of their rideshare business. SpaceX conducts a few rideshare launches each year where they carry many small satellite payloads in a single Falcon 9 and deploy them all into low Earth orbit. The wait time for a customer to get on one of those missions is around 2 years. SpaceX could fill their manifest for twice as many rideshare missions as they currently perform and reduce wait time significantly. They choose not to do this, though, because their rideshare missions are simply not high-value launches. It is operationally intensive to work with many customers to pack potentially over 100 satellites into a single rocket, and then those customers are extremely price-sensitive. Instead, SpaceX chooses to focus on pricier services like crewed missions to the International Space Station, expensive national security and commercial satellites, or Starlink deployment, which SpaceX hopes will bring significant recurring revenue for the company. So when we do look forward to the introduction of Starship, why would SpaceX be incentivized to dedicate many missions to small satellite payloads when it would have to work with hundreds or even thousands of customers to fill a single Starship with CubeSats? While Musk states the company could potentially conduct up to 3 Starship launches per day, it'll take years to get to that launch cadence. In the early days and years of Starship, SpaceX is still going to prioritize deploying Starlink, delivering high-value human landing system missions for NASA, and maturing the technology required to put humans on Mars. On top of that, what competition is going to pressure SpaceX to bring its pricing anywhere close to its marginal cost of $10 million a launch? If Starship can put 100,000 kilograms in low Earth orbit, its nearest competitor by payload class is NASA's Space Launch System, which was most recently approximated to cost over $4 billion a launch. Starship is likely to be priced early on somewhere around the $150 million to $250 million per launch mark. At that price, Starship will still be a great deal for customers at only about 1.5 times the price of a Falcon Heavy, while carrying more than 2 times the mass and volume to LEO than a Falcon Heavy. The cost per kilogram in that price range would be somewhere around $1,500 to $2,500 per kilogram to low Earth orbit. That would be on a full Starship, but keep in mind that a rideshare Starship for small sats would be carrying much less than its full 100-ton payload capacity, and so the price per kilogram would get higher. So in the middle of that range, $2,000 per kilogram, we're talking about a 42% reduction in price below Falcon 9's cost per kilogram of $3,400. That's an incredible benefit to the industry, but it's not in the order of magnitude or greater price reduction that we see too many hoping for. And that'll do it for today's episode. We hope you enjoyed it and learned something new. Please let us know what you think in the comments section below. Your feedback is very important to us and helps us make better videos for you. Thank you so much for watching, and see you next time. Bye.